So welcome students. In the previous video we have seen the introduction for the law of natural decay and we have seen one problem on that. So in this lecture we will move forward with one more example. So let us observe the example. Here it is given as uranium decomposes at a rate proportional to the amount present at the time if M1 and M2 grams of uranium present at T1 and T2, then find the half-life of uranium. So that is the given problem. So as we have discussed earlier, we solve this problem with the help of law of natural decay. So because the uranium decomposes here, so therefore we have to apply law of natural decay. By the law we have that N is equal to C into e power minus kT. Of course, where K is the proportionality constant which is always positive. So let us once again write what are all the variables represents here. So here N represents the amount of uranium, and C the arbitrary constant, and K greater than 0 proportionality constant, and of course finally T the time. So we solve this problem in 3 steps. So as usually in step 1, so step 1 we will calculate the arbitrary constant. To find the value of C. C means that arbitrary constant we will calculate first of all. So to find the value of the arbitrary constant we have to take the initial condition. But here the initial amount of uranium is not mentioned. Only at T1 and T2 how much of uranium we have, that one only mentioned. That's why let us assume let N is equal to N naught amount of material be present initially. Initially means at a time T is equal to 0. So therefore by using equation 1, so if you substitute all these values, N value is N naught is equal to C into e power minus K into T value is 0. So if we simplify this as e power 0 is 1, so we get C is equal to N naught. So by substituting the value of C is equal to N naught in equation 1, we get the new equation as N is equal to N naught into e power minus kT. So this is our new equation now. So now from the step 1 we got the value of the arbitrary constant. From step 2 we find the value of the proportionality constant, that we can write to find the value of K. The proportionality constant we will calculate now. So for which here one condition is given. It is given as M1 and M2 grams of uranium present at T1 and T2. So by using that condition we will find the value of K. So now we can write it as from the hypothesis we have, or otherwise given that N is equal to M1, in the sense M1 grams at T is equal to T1. Okay, and similarly N is equal to M2 grams at T is equal to T2. So by using these two, take these two as some equation A and equation B. So by using these two equations we will find the value of K. Just all of you observe this. Okay, so from equation 2 and A, means if you substitute the values whatever we got in equation A, if we substitute, we will get n value is m1 is equal to c into e power minus k into t1. So similarly, if we substitute equation B, in the sense the values that what we have in equation so from equation 2 and B, so here n value is given as m2 and t is t2, so therefore we will get, if we replace the values in place of n and t, we get m2 is equal to c into e power minus k t2. Okay, so here actually we have c value as n naught, okay, you take these two equations as some c and this one as some d. Now our aim is to find out the k value in this case, so therefore now you consider, simplify the equations c and d, then we get LHS side we have m1 divided by m2 and RHS side we have n naught into e power minus k t1 above n naught into e power minus k t2. So here we get like this. After simplifying this, we will get m1 by m2 is equal to e power minus k t1 plus k t2 we get. So this implies we get m1 by m2 is equal to e power of, if you take k as common, we get t2 minus t1. Okay, simply now if we will simplify this, k into t2 minus t1 is equal to log of m1 by m2. This is what we got, or otherwise finally if we want the k value, finally we can write k is equal to log of m1 by m2 divided by t2 minus t1. Now by using this k value, finally we will okay, now we will discuss step 3. Sorry. In step 3, actually here it was asked to find the half-life let me okay, half-life means, what do you mean by that? Half-life means, let me tell you, initially we have n naught, okay, as initially we have n naught, so now half-life means, so 50% of this means n naught by 2 we need to calculate, means in the sense we need to calculate the time for which n becomes n naught by 2. In the sense, to find the half-life of uranium means that is to find that is to find the time t at for n is equal to n naught by 2. Half life means in the initially we have n naught, half life means n naught by 2 we need to calculate. So means we need to calculate the time for which n becomes n naught by 2 we need to calculate. So again we will go for the formula, that is nothing but from equation 2 actually we have, okay, if we apply equation 2, that n becomes now n naught by 2, n naught by 2 is equal to n naught into e power minus k into t value, that what exactly we need to find. So here n naught cancels out and we will get 1 by 2 is equal to e power minus kt we can write, or otherwise we can write e power kt is equal to 2, means t is equal to 1 by k into log of 2 we get. Now what is that k value? K value here we have log of m1 by m2 divided by t2 minus t1, that if you substitute here then we will get the t value as this t2 by t1, t2 minus t1 is in the denominator, but here it goes to the numerator, means as we have to take the reciprocal. So t2 minus t1 into log of 2 divided by, so in the k value here we have log of m1 by m2, log of m1 by m2. So this is how we can find out the half-life of uranium. So this is the final answer. So once again let me conclude this. So as usually we need to find out the half-life of uranium in the sense, okay, here we can divide this one into 3 steps. In step 1 we have to find out the value of C, in step 2 we have to find out the value of K, and in step 3 we have to find out the final result what we need to exactly evaluate. So this is the procedure 99.9% in almost all the problems we can adopt. So both in the law of natural growth and decay, whenever to find out the final result, let us divide all the problems into 3 steps. In step 1 we will calculate the arbitrary constant value, step 2 we will calculate the proportionality constant value, and in step 3 final result we have to calculate. And this is how we can proceed. In the future videos we will discuss about some more applications. Thank you one and all.